Okay. Excuse me. So, hello, my name is Felipe Herrera, and this is my Physics 2211 Lab 3. Introduction. The purpose of this lab is to find the mass of a black hole by utilizing a star's orbit, and then using this to find the initial velocity a ship must have when it leaves the surface of the planet to avoid the black hole without crashing. So fundamental principles that we're using is Newton's second law, F net equals mass times acceleration, and Newton's universal law of gravitation. So some concepts. The only forces acting on the star is the gravity from the black hole, and the forces acting on the spaceship are gravity from the black hole and the planet. And V average equals V final because we're working with a non-constant force being universal gravitation. So here's the initial code for finding mass. Oh, excuse me. And here's the code for finding the mass of the black hole. Okay, so here's what I got for the mass of the black hole. I got the mass of the black hole to be 1.1775 e to the times 10 to the 34, and it's a big black hole. And then the magnitude of force net I got to be 0.421806 newtons, and force net parallel being 0.054213 newtons, and force net perpendicular being 0.418605 newtons. Initial conditions for initial velocity of the spaceship. Here's my code. So then this is the code for calculating net force on the spaceship. And here's the code for the initial velocity of the spaceship. So then here's the findings that I got. That should be 1 negative, but the initial velocity of the spaceship being negative 9.04 e to the 6, 8.84 e to the 6 in the y component, and then 0 in the z component, and then meters per second. And the closest distance between the spaceship and the black hole I found to be 5.01 e to the 9 meters. And those results could have a lot of human error because in part 1 I probably didn't run my code long enough to get a precise mass for the black hole, and then on part 2 I kind of had to guess the initial velocity by just doing like plug and chug until it worked and I didn't hit the planet. So also the time interval could be short. So what if I wanted to orbit the black hole instead? If I wanted to orbit the black hole, then the initial velocity of the ship would have to be a little less than I had it be. And while I was not able to figure this one out, I believe that the y component would need to be larger and the x component be smaller because it moved a little bit too far in the x. So what does it mean in the first part? For the first part, F parallel is the net force parallel to the direction of the object's momentum. F perpendicular is the net force perpendicular to the direction of the object's momentum. Net force is the change in momentum over the change in time. The rate of change in momentum is the final momentum minus the initial momentum divided by the change in time. Momentum is mass times velocity. It's easier to find the change in momentum than it is to find the net force on an object. So yeah, thank you for watching.